Hello guys, hi, how are you? Hope you all are doing good. And I'm back with the seventh part of basic mathematics. Let me introduce myself. I'm Arshad, a senior physics faculty, Pondicherry Center, an academy. And those who are nearby this city, they can visit our center and confirm their seats. And let's see in the offline classes and let's crack it all together. So now, hi guys, hope you all are doing good and enjoying the videos. Yeah, I'm sorry for being late because of my busy schedule. I couldn't bring videos, but now I'm free. I'm going to bring everyday videos for you, and I'll finish the syllabus as fast as possible. I know you people are waiting for the videos and hope these videos are benefiting you. So let's start. See, differentiation we discussed in last video. Let me recap that and try to understand once again. So differentiation means if I'm trying to differentiate or divide a large section into a smaller section, then we are saying differentiated part. This is the meaning of differentiation. But we discussed why we are discussing differentiation, and first we discussed the formulas, right? So what are the formulas of differentiation, sir? Differentiation of formulas of let's talk about x to the power n. So it is going to be nx n power minus 1, right? Similarly, if I am talking about the differentiation of x, it is going to be 1. So please once go through all the differentiation formulas, because we already had discussed rules of differentiation, we discussed, and then we discussed what are the rules. We discussed one by one each rules, right? Hope you already gone through everything. Now and then we discuss application of differentiation, and in application of differentiation I told you first application is slope of a curve. So how to calculate slope of a curve, you just revise it. And rate of change of differentiation, it is also given. Rate of change of, see what is this rate of change of a function? What is this? Whenever you are something is changing, then not only with respect to x, it may be with respect to time, with respect to anything, then the differentiated value is giving this rate, right? The next is maxima and minima. We discussed the maxima minima conditions also. So please once go through the last video and you will get more clarity on this. Now today's video will be for integration, sir. Now let's talk about integration. Let me introduce myself. My name is Arshad Hussain. I'm a senior physics faculty in an academy, Pondicherry. Here I'm taking the videos for IIT, JEE and NEET, and these videos are for basic mathematics used in physics. So hope you all are enjoying it. So let's proceed this. Sir, I'm going to discuss here is integration. Integration. What is integration, sir? It's the inverse process or reverse process of differentiation. Reverse process of differentiation. Sir, what is the why we are doing integration? Sir, in differentiation process we divided the large part into smaller parts. Now in integration we are going to add. Actually the meaning of integration is addition. Addition of what, sir? Continuous system. If I am talking about discrete, you can count it 1, 2, 3, 4, 5. You can add it using the summation sign. But here, if a system is continuously changing, means these are not in discrete form. What are these terminology? I will let you know over the time. But you understood what is the meaning of integration, means addition process, right? So symbol of integration is this, sir. With a, sir, integration of f of x dx. Integration sign and dx will come together. It may be dx, it may be dt, it may be anything, but d will be there, right? This is the symbol. Next, sir, what are the formulas, sir? First let me talk about formula of integration. Sir, integral formulas, let me discuss in detail. Yeah. Sir, first formula is integration of x to the power n dx, as that of differentiation first formula was same, right? Sir, what will be this, sir? Integration of x to the power n is x to the power n plus 1 by n plus 1. A constant c I will give here. Why I am giving this constant c, I will let you know. Okay, so a constant c I am giving. Second, integration of dx. Dx means here x power 0, sir. Then what is this? X power 0 plus 1. So it is going to be x plus c. Similarly, third, integration of what, sir? Here integration of e to the power x dx. What will be the integration of e to the power x dx, sir? E to the power x. Let's see. Integration and differentiation of a function that is e to the power x is same, sir. It does not change. Okay. Next, fourth, integration of ln x. Wait a second. 1 by x dx. Integration of 1 by x dx is nothing, it is ln x. Let's see. Why? Because differentiation of ln x was 1 by x, that's why integration of 1 by x dx is ln x plus c. Keep in mind, sir. Fifth, sir, integration of sin x dx. What is the integration of sin x dx, sir? Sir, cos differentiation was minus sin x. Now minus, here minus is not present, so I will give minus this side, sir. Minus cos x plus c. Sixth, sir, integration of cos x dx. What is the integration of cos x dx, sir? What was the differentiation of sin x, sir? It was cos x. So cos x integration will be sin x. Let's see. Similarly, integration of sec x into tan x dx. So what was the differentiation of sec x, sir? Sec x into tan x. So here integration of sec x into tan x is sec x plus c. Yeah, sorry. Now, sir, integration of cosec x into cot x is what, sir? Sir, integration of cosec x into cot x is minus. Why minus, sir? Because see, sorry, yeah, minus will come. You know, differentiation of cosec x was minus cosec x into cot x, but here minus is not present in the left side, so I will have to give in the right side. What is that, sir? Cosec x plus c. Similarly, integration of sec square x dx. What is the integration, sir? Sir, integration of sec square. What is the differentiation of tan x, sir? It was sec square x. So integration will be tan x plus c. Similarly, what is the integration of cosec square x, sir? You know, the differentiation of cot x is minus cosec square x. So minus is not there here. So I will have to give in the right side. So minus, sorry, cot x plus c. Hope you understood up to here. See, these are the differential formulas you should remember, sir. And here we are talking about indefinite integration. Keep in mind, we will talk two types of integration, sir. One is indefinite integration, the other is definite integration. No problem, I will give you an idea. Now let me talk about the types, then we will discuss the rules, sir. Now types of integration. How many types of integration we are going to discuss, sir? Two types, sir. One is indefinite integration, the other is definite, sir. Why we are saying indefinite integration? What I told, sir, integration is the reverse process of differentiation, right? So let me prove it. Let me prove this statement, sir. So now if you will observe, let's say differentiation of, I am doing 2x plus 1, let's say, with respect to x. So what I am getting, sir? It is 2 plus 0, differentiation of 1 is 0, so it is going to be 2. Sir, if I am integrating 2, what I am getting? So let me do this. Integration of 2 dx. What I am getting, sir? It is 2x. Sir, this constant is missing, sir. Is it there in after integration? No. If you don't know this constant, so how you, sir, if in front of us we can see we differentiated 2x plus 1, that's why we got 2, and we integrated 2 and we are getting 2x, but we know here it was 1, so we can keep it 1. But if only simply a question is given, let's say like this, 2x plus 3, like this, sir, you are asked to integrate it, so you will write like this, 2x square by 2 plus 3x. Here, do you know what is the constant missing here? Here you don't know what is the constant, sir. That's why after integration of indefinite integrals, you will have to give a constant c, because this constant is always missing, sir. So that constant you will have to keep, and you don't know that constant. So now, sir, can you let me know, if I am not putting the limits, what are the limits? You understood, sir, indefinite. Now what is definite integration? So this is the example of indefinite I gave. Now let me give you the example of definite integration. Sir, in definite integration, what are the things I am going to do? Definite integration. Sir, in case of definite integration, I'll put, sir, let's say I'm integrating f of x dx, and I got g of x of. Now, sir, here limits I will put, sir, a to b. What are these, sir? These are the values of x, right? Sir, if you want to integrate a function from the value of a to the value of b, then you will have to put the values here, whatever output function you got, a to b, and then you put upper limit. First you should put upper limit, so g of b minus g of a. Sir, what application? Sir, let's say I ask you to integrate. What integration, sir? Let's say integration of x dx. Simply for your example, let's say 1 to 2 limits I gave. So what will be this, sir? Can you let me know the integration here? Sir, x power n formula. So you can reply, sir, it is x square by 2. Limits from 1 to 2. Put the upper limit, sir. It's a 2 square by 2 minus 1 square by 2. Upper limit minus lower limit. So first you should put the value of x from upper limit. Then you should put the value of x in lower limit. In between you should write subtraction here, this sign. Got it? Hope you understood this. Sorry. Now, sir, if you, after solving, let's solve with this. Sir, it is 4 minus 1 is 3. So 3 by 2 answer, sir. Sorry, 3 by 2. Three by 2 is the answer. Sir, here don't need to give a constant c. Why, sir? Because in case of definite integration, what I am doing, I am putting the limits, sir, 1 to 2. So in case of definite integration, don't need to give any constant. Without constant, the numerical value you will get, right? Hope you understood this. Now let's talk about the rules of integration. Now give the heading rules of integration. Rules are important, sir, so you should go through rules also, very important, sir. Now first rule, sir, rule number first. What is rule number first, sir? Based on formulas you can apply the formula, but you should know the rules. For first rule, let's talk about, sir, if you have a constant that is multiplied with f of x, then you will have to take this constant out, then integrate the function as it is following the formulas, right? Example, sir. Okay, you gave this formula. What is the example here, sir? Let me give you an example of this rule. Sir, let's say you have 2x square dx and you want to integrate it. You know, 2 is a constant, just like our formula, k is a constant. So 2 is also a constant here. So 2 will come out as it is, as per the formula, as per the rule. Next, integration of x square dx. Now what is doing, sir? 2 is already out, and x square integration, you know what is the integration of x square? So x to the power n. See this formula, sir. So x to the power n plus 1 by n plus 1. So what is this, sir? Here x to the power n plus 1 means 2 plus 1 is 3 divided by 3. So what is the answer, sir? Finally, sir, 2 by 3 x power 3 plus c. Why I am giving c, sir? Because it is an indefinite integration, sir. Limits are not given. For if limits are given a to b, then you can easily put the values and get the answer in the form of numerical values. So if you are getting numerical value, then why to give a constant? Because constant is already included in terms of limits, sir. So no need to write here. In this case, you will have to write a constant. For definite case, you don't need to write any constant, sir. Now next, I am talking about rule number 2, sir. So rule number 2 states that if you have two functions, f of x plus g of x, and both together you are planning to integrate. Sir, how to do, sir? Sir, just simply likewise differentiation. In case of differentiation, we did the same thing. You should differentiate first f of x, integrate first f of x, then plus or minus, it may be minus also, integration of g of x. Simple rule, sir. Now example, sir. Integration of, let's say you are asking integration of x square plus x dx. So here are two terms, x square and x, both are together with a addition sign. So now what I will do, sir? Integration of x square dx first I will do, plus integration of x dx I will do, just like as per the rule. So what I will do, sir? Integration of x square is x power 3 by 3, and integration of x is x power 1 na, so that is x power 2 by 2, isn't it? So now answer is, after further solution if you want to do it, otherwise this is the after integration, this is the function we got, sir, and this is the answer, sir. And a constant is also there. Wait a second, a constant you should write. Why? Because it is indefinite integration. Next, rule number 3. So rule number 3 states that if you have a function f of x that is multiplied with g of x, and you want to differentiate this function, these two functions together. Sir, I told you this type of form you can write u into v also, because f of x is nothing, it is u, g of x is nothing, it is v. So in terms of u v, it will be better to remember this. So consider this u, and this is v, sir, right? So if you want to write u into v form, so now let me integrate it, sir. Sir, what will be, just keep v as it is. So v means g of x. Wait a second, u into v form. Wait, sorry, my mistake. No need to it. It's not a differential, sir. Sorry. Sir, now what you need to do, sir? Sir, always keep in mind u integration of v dx minus integration of bracket close du by dx integration of v dx bracket close again dx. This is the formula you should remember, sir. Very important, sir. If you, this is u and this is v, sir. Example, sir. Simple example I am giving to you. Let's say you have integration of two functions you have. One is uh, x into e to the power x. Let's say this is the integration you have, or not, don't take this also. Wait a second, let me take a simple solution. So simple example, sir. Simple example is, let's say trigonometric function, let's take it. So x sin x, sir, integration of dx you want to do. Sir, what you can do, sir? First, what I told, make u, sir, u and v how to consider. I am giving a rule, sir. For your better understanding, I am giving a rule. L, I, A, T, E. Sir, which function will come, whichever will come first will be u, and the here see, this side is always u and this side is always v, sir. Let me show you. L means logarithmic functions. What is logarithmic function, sir? Log, let's say log x or ln x, whatever is written, then it is logarithmic function. Second, sir, I means inverse trigonometric function, metric function. Okay, so what is the example, sir? Here examples are tan x, sec x, like this. Sir, a means, here a means algebraic expressions. Algebraic expressions means, let's say 2x square. This is algebraic expression. Now this is, sorry, inverse trigonometry, no, sorry, my mistake. Tan inverse x sec inverse sec inverse x. Now t means trigonometric functions, metric functions. Sir, in trigonometric function you will take examples sin x, tan x, etc, etc. Now last one is e, sir. This is e. What is the meaning of this, sir? Exponential functions, sir. Exponential functions. What is the meaning of exponential functions, sir? Here I am saying, sir, let's say e to the power x, a to the power x, etc. These are exponential functions. Okay, so whenever these type of functions are coming, these are called exponential functions. So which will come first will become u, and which will comes last, it will become v, sir. Let me show you, sir. In this case, what is coming first, sir? Sir, first x is algebraic function and sin is trigonometric function. So a and t, it's continuous now, see, algebraic. So a, it means first term is going to be u, second term is going to be v. Why? Because see, a is coming first and then t is coming. So this rule you should remember, LIATE, right? Now can we integrate this function then? X sin x dx. What is the rule saying, sir? Sir, the rule is saying u v dx. U is what, sir? X. Integration of v dx means sin x dx, minus integration of what, sir? Du by dx. So u is what, sir? X. Now integration of, this is into, sir, multiplication. Integration of v dx, sir. So sin x dx into close integral, means bracket close and into dx. What is the integration? X will be as it is, integration of sin x is, sir, you know, minus cos x, minus integration of differentiation of, I will write integration as it is, bracket close. Now differentiation of x with respect to x is 1 into integration of sin x is minus of cos x. So I will write here directly minus. What is now, sir? Now answer is very easy, minus x my cos x plus integration of cos x is sin x, and a constant c you will have to give at the end. This is the process to integrate when two functions are in the form of multiplication. Got it? Hope you understood it, right? So for division form is not required. Why? Let's say you have something x to the power, let's say x e to the power x by e to the power x is given function. So you can write this na, x to the power minus x. Similarly, if a function is given like this, x by sin x, so you can write like this, x to the power x sin x to the power minus 1, x power minus 1, sin x power minus 1. So you can write similarly, let's say you have sin x by x power 3 is given. So you can write sin x x power minus 3. So in this form you can convert u into v form. These are all u into v form. You can convert into u into v form and you can get the answer quickly, easily, sir. Got it? Hope you understood this and with examples also. So this is the, now next let's finish the application part also. So what are the applications, sir? Sir, if I am talking about the applications of integration, sir, here integration application is very wide, sir, but we are talking about the basic things, so you should understand where and why we should apply integration, sir. See, if you have discrete thing, you can add, right? If I am asking you simple question, I am asking you, let's say if you have a square, if I am asking you what is the area of this square, sir, you will say, sir, area will be equal to a side square. Sir, let's say you have a rectangle, length and breadth, sir, area is equal to length into breadth. If I am giving you symmetric figure, you can quickly answer it, what is this area. But if I have a shape like this, let me show you, a shape like this, any irregular shape it is, right? And we know this function value, means let's say it's a curve, right? It's a curve, and that curve's function value we know in terms of x, we know this is x, this is y, and this is function, means this is y value actually. Sir, my question is, if I'm interested to calculate this area, how I will do, sir? Sir, here integration comes. Sir, whenever you want to integrate an area of irregular surface, then you should divide into small pieces. That is the differentiation process. I already taught you. You should differentiate it into small pieces, and then if you are observing, sir, small pieces are looking like rectangles, small rectangles. Sir, if I am saying the thickness of this is dx and the height is y, already you know this, the height is y, sir. So can we calculate this area, dA area? Yes. What is this differentiated area, sir? So differentiated area here is small area, means differentiated area means small area. So what is this, sir? Here it is y, length into breadth, so length is y, breadth is dx. If I want total area, I will integrate it, sir, both side. So limits, because this is definite, because we know, if we know the limits, let's say here x equal to a to x equal to b, because x values you will know, na, sir, from where to where I need to calculate. Sir, if you know the limits, so you will put a and here it is b. So after integration, you are going to get the answer. Sir, what is y? Y is nothing, it's function of x into dx. Integrate a to b, and then you will get the total area, sir. This is the first application and very vital application, sir. It always gives area under the curve. Integration gives, so what you will write? Area under the integration gives area under a curve. Okay, keep in mind, sir, very important, and actually in physics widely I am going to use this, because without integration you won't think to solve physics question. So this much huge application are there. So please focus in application parts, and hope you understood the video, and please like, comment and share, and don't forget to subscribe the channel if you are new in this channel. Yeah, regularly I will try to bring the videos, because of the time issues sometime I'm unable to update the videos on time, but yeah, I'm trying to make the videos on my priority basis. Thank you so much.